itself. And we have been doing it for like 5-6 years, and then finally launched that product. But for the robots, right, for those devices, I mean, there is at most 100 parts. So managing supply chain, managing quality, logistic, as well as manufacturing is much simpler from a hardware perspective compared to building cars. And the homologation compliance requirement, as of now, the standard is much simpler, easier as well. The only certification we have to do is the communication, FCC, Federal Communication Committee certification as a electric product, as an electronic product. Other than that, you're certified, you're able to sell, which we are right now. So I would say that it's solving the real world needs. Building hardware of the robot is simpler compared to building cars, but training the brain is actually very difficult. So I think that's the bottleneck, that's the hurdle. That's where the value is creating, no matter with Figure or with Tesla or with NVIDIA or with great physical AI or physical model, real world model companies. I think that's the core value. Thank you.
Thank you, Jerry. I think Kazuki-san has a solution, and then I know that a lot of our portfolio company like Answer Energy, they're building manufacturing of batteries in Kentucky these days, and they just it was one of my first time to really went to a ribbon cutting ceremony in the U.S. Yeah, so that's so amazing. But a lot of the parts, actually, a lot of the machinery was actually built in Japan. And obviously, Japan has world-class strengths in manufacturing and hardware engineering. So how do you see these two ecosystems? And US is definitely in frontier AI software, as Eva just mentioned. So how do you feel like these two ecosystems collaborating the next generation of robotics?
My name is Kazuki. I'm from working at Sumitomo Heavy Industries. So I see many what's being needed for the humanoid robot. I saw many people try to make a same humanoid as a try to make a human robot same as the humans. But I think we need to focus on how the human robot can become a really good friend with human workers and machine staff. And in concretely, we need to have some kind of system to the robot is collaborate with flexibility with the human and machine staff. The people usually focus on the mass production and because it's easy to scale up the business. But in the real, in our factory or in the real life, there's a high mix low volume tasks, and it's hard to make a really complete, really great robot, humanoid robot. It's hard. In our factory, we are because heavy and large manufacturing. There's some many tasks which human cannot do, like bring a heavy object. So right now, the human worker try to assemble the parts, but during assemble the parts, they need to bring something from the other places to bring the part. If the robot can do this heavy task, the human worker can focus on how to do the assembly task. The human can focus on the expert skill itself. And then the human robot, the operator can give the flexibility to the human robot that which part, where, and where should bring, what should be done. So in our industrial field, there are so many tasks that we need to develop the robotic stuff. And how we should collaborate with the USA company and Japanese. This is some kind of my personal opinion, but this is our company. Maybe Japanese company was good at manufacturing hardware stuff. And then the American side, that there's so many software startup which is good at innovation stuff. And we need help to American startup for the making innovation of productive step. On the other hand, that I want that the American startup should respect also Japan. Our company have good at the hardware or manufacturing stuff. The important things is we won't keep the manufacturing knowledge or technology inside our company or Japan because it's core stuff. So if we try to collaborate with some software startup in America, maybe we will use their software module. We will train inside. Maybe we can work by making black box software module, but maybe we can use a trained AI model and try to make better in America factory or environment for new business for our company stuff. And also what is important, what is with USA is one of the largest market. But we Japanese company don't know what is the real needed in here. So we need to figure out what is the customer needs in the Americas. So this is the one of example. We are trying to make better autonomous teleoperation excavators. We want to collaborate with some startup maybe which have better hardware stuff, hardware component make safer stuff. And this startup can try to collaborate with some local company in USA to do some simple product. And if they did some simple product, they can show to Japanese company their performance or their idea stuff. It is hard for our company to directly collaborate without seeing the result. If they have some simple basic result, then I can tell, and also if we can try to understand with startup to what is the market needs in the American company, then I can explain to business need. Oh, America they have this business, this market. This startup can help us to making products. So why not to make a joint research POC? Then finally we can improve our product, their innovation technology, and bring this product back to USA to make better factory environment. So this is my personal thinking, but I won't make this kind of collaboration with American startup.
This was actually my favorite slides. That's why we're showing here. When I was talking with Suki-san, and I really like this. Yeah, and then I also like in Japan. I went to Japan, and then I feel like the people, the adoption of robots actually faster than here. Because here, people hate the idea of a labor replacement. But in Japan, you know, people grew up with like Hello Kitty, so cute. They are my friends, right? They're not trying to replace me. And then, so I felt like a lot of our robotic company, their immediate market is actually not Silicon Valley. It's actually Japan. Yeah. So that's actually something that we definitely wanted to collaborate. Two-way collaboration here. All right. So coming back to Dr. Chu, I know that the whole thing, you know, the reason why we're having an event here because at the Mino, we have people from OpenAI, from NVIDIA, and then from Meta and Google. A lot of us actually purchased the humanoid robots and wanted to do this at home and trying to create a reading club, like a paper reading club to reproduce, you know, what's in the paper. And then, so this club seems to us, not just for investment, but also for curiosity. And why do you think it's important to actually like talents to come together and to learn about physical AI? Especially we're probably 10 years ahead of mass adoption, right? So.
Yeah, that's why we want to set up the robotics and LLM university today, because I think it's still a very early stage for humanoids to get into household. We see three types of people working maybe interested in robotics. The first type is AI researchers and maybe AI robotic brain developers. They are interested in developing intelligence for robotics, but they may not have access to all the different types of robotics, like Foley robotics. They may have some unitary robotics, but they want to try different types of robotics, different types of humanoids. Not everyone have access to these types of hardware. Then there are the hardware developers. like Unitree in China, Zhiyuan, and other startups. They have the hardware. They, the robotics, just like this Ferrari one. It's very agile. They can dance. They can kick. They can walk around. But their intelligence is still primitive. They cannot do daily tasks like pick up a glass, make your bed, and things like that. They want to collaborate with the software developers. I think the third one, as you mentioned, the settings in Japan, right? There are a lot of potential customers, but they don't really know what's going on, that how capable the robotics and are today. They have the application, the settings, the scenario, but they don't have the expertise to help them deploy the robots. We want to bring the team together to set up we call the robotics university. We also want to we actually have found some space. Like this space is very small, right? You can't really do much with this small space. But we work with real estate owners, developers to set up a big space where they can set up some scenes like a restaurant setup or a factory setup, just to give software hardware developers an opportunity to try their program, to try their robots and see how they work well and in those environments. I think it's just get people together, connect everyone, and it's definitely very helpful, especially at this very early stage.
Yeah, this is one of the projects that actually what Unitree can do with Amazon. Not really. Okay, it's moving. So you can voice command, but it's very, very hard to program. That's why we have the paper reading club to actually reproduce. A lot of them were VP and Meta, so a lot of them were very, very technical. So I think in Silicon Valley nowadays there are a lot of such kind of paper reading clubs. Yeah, and then we make sure that the one that we have, every single one of them, they do have a robot at home. So this is for getting your Unitree to bring your trash can from your garage to the curb. So we're not trying to build a word model or anything. We invested one, but we're not trying to build one. We're just trying to see what the platform really can get normal people. Yeah. So I'm sure that Erla has the very fancy ones at the AWS, right? So among those fancy ones, how do you feel like? Right now we can only do demo and then dance and only a couple of demos, and we have to make sure they doesn't actually exist certain weights, because otherwise you can push them. And then sometimes you want to grab something and over a couple times and the finger just flipped. And then how do you feel like, what kind of pattern have you seen among teams that successfully operated nice physical AI in real world environment versus demo environment?
Yeah, it's a great question. I think about scale and starting something with focus and function, right? You're trying to solve a very specific problem. I don't know if most people in this room know, but Amazon is the largest singular deployer of robotics in the world. We have over 1 million robots operating today across our entire fulfillment network. And all of that technology is powered by AWS. But I will say, you think about the scale of this, it was never 1 million to start. everything that you're seeing typically in our warehouse, but even I would say in the industry, because we work with Teleexistence in Japan, Config Intelligence, We Robotics out of Korea, and everywhere else across the globe. Some of these companies are really building kind of breakthrough solutions, but they start with a solution that's very purpose-built. It is solving a real pain point. And I think we are maybe missing a little bit of the current that I want to articulate, which is the hardware is getting cheaper, right, to access. The models are getting better, right? Sensors are getting better, LiDAR, the funding. We talk about funding. In 2024, about $7.2 billion was invested in robotics and physical AI companies. A year later, it was 40.7 billion. As of May this year, 26 billion is what's been invested in robotics and physical AI. The numbers are staggering, but then also the economics now. Like you have this trifecta of a perfect, I call it a perfect storm. It shouldn't be a storm. It's like a revolution, I think, in what physical AI can do. And what it's doing is it's solving real world challenge problem statements. So I think about, Teleexistence having a full stack from a robot that actually is purpose-built. They actually do have a humanoid. They build a model. They do quite a lot of the data training pipeline, real-world data, simulated data, and they're already in hundreds of convenience stores all across Japan now, touching 7-Eleven in Japan and probably internationally, right? We have companies like Luminous Robotics who are actually helping install autonomously robotic panels in fields. Now, it's interesting, if you know anything about the solar industry, even the panels were designed to a certain size because it was designed based on human capability. So it's not meant to be more than 100 pounds, so 2 adults can lift that product. But if you change the human element, you can actually change the whole form factor. How big can the panels be? How much can they process? So reimagining this entire experience, but it's starting with a problem. Sue, to your point, it's a very specific problem. And data is not an option. Data is part of the infrastructure from the very beginning. I know there's a lot of work being put, of course, with our NVIDIA partners. It's with the Cosmos stack, with simulation, but simulation is all good until it gets to 80% accurate. And in the space of physical AI, 80% is not good enough when we're talking about autonomous cars on the road, systems in hospitals, carrying your children, your elderly, an autonomous cargo ship in the middle of the ocean, God forbid it falls on you, or a child in the airport, 80% is not good enough. And so thinking about how are you collecting that data from the very beginning, building it, spending the time, and it's not even necessarily volume. We do have a challenge because it's not like a large language model where you have 100 billion parameters and it's pulling every encyclopedia in the world and it's telling you who the 17th president is. That's not how physical AI works. It's built on sensor and motion and touch. That's very different types of data that's very custom bespoke. And so how do you aggregate that information? But it's actually not just waiting for the volume. The companies that I've seen successful are also actually managing that pipeline, organizing, actually structuring that data very early on. So while they're waiting to build more data, real world data and simulated data, they're actually right factor forming it from the beginning. The other piece I'll just say, the companies that I see are very successful in this space are thinking about edge deployment. Like this is a millisecond situation. You can't wait for a model to process, to run back onto cloud, to come back and deploy a policy. That doesn't work, right? When you have a 4,000-pound object moving something, it just can't fail. There is no failure as an option. So thinking about immediately what is that edge process going to look like, and thinking about the fleet, because the assumption is you're not going to just deploy one of something, you're going to deploy a fleet. And how do you orchestrate that? That kind of thinking is starting at the beginning. And the last piece I'll probably touch is thinking about safety policies at the beginning. Like physical world means physical objects, all kinds of physical objects. And so when they're starting to interact with people, like you start to think about safety or responsibility. What does this mean, the implications of it? And the companies that I find are effectively building in this space are thinking about this from the very beginning.
I totally agree, because I was totally qualified for the first panel as your master, but I really need her expertise here. So I totally agree, and yeah, that actually set up a guidance for amino sequencing thing as as well. All right, so yeah, so Jerry, and then I know that logistic, vehicle, and this is like your territory, and then now you're in like robotics, and then how do you see robotics becoming an extension of intelligent vehicle system, which is pretty mature these days, right? And I'm using FSD and everything. So, or this can evolve into something completely different, software platform, hardware.
Yeah, that's a very good question. I would say that from a software architecture perspective, maybe like 2 layers. One is, or probably 3. And one is from an operating system perspective. They're kind of similar. Those products, at least our product runs on Android, and we built the unified Android operating system platform for our robot as well as our cars. So people always use Android. There's a great application developer community on top of that, and you have access. You're very familiar with it. So operating system is just a natural extension of what we have been doing on the automotive side. And second is the control unit, right? So for the cars, you control it forward, backward, left, right. For the robots, no matter humanoid or quadrupeds, you control all of these movements with all the electric and electronic architecture that you built. So this is kind of similar as well, although controlling a robot is like 100 times difficult or more complex compared to controlling cars. But still, those are natural extension from the automotive perspective. And the third, I think, is mostly complex, which the panelists all touched, is the model that they use, especially the AI part. That is super complex. I think that's also a natural extension compared to the let's say that the AI model, the physical AI device or the robot will use. FSD is actually quite simple. If you think of that, right? Tesla spent, tens or hundreds of $billions into FSD and bring it to this point. So it's almost full autonomous driving, 99% there. I think it will be done in the next 1 or 2 years, but lots of money and lots of time has been spent. But actually compared to the robot can carry specific tasks, having car be autonomous drivable is much simpler because there's only 4 degrees of freedom, 4 degrees of movement for the automotive. It's front, back, left, and right. But the hand, only one single human hand, we have like 25, 26 degrees of freedom. This is super complex. And think of that. I'm holding a mic right now, right? So this is super complex task. It's very straightforward for us, like human beings, to do. But actually think of a robot. First, it needs to know what is a microphone. And second, by seeing it, it needs to understand if I don't hold it, the microphone will drop. That's a word model can tell or can be deployed with this product. And third is that the touch and feel, I'm saying this is like metal, so it's not super slippery. It's pretty firm, so I can hold it with some more pressure. And with the structure of my 5 fingers, it can generally be stable. Those are all the knowledge or the word model should tell a robot to do. And where do you get this data? It's actually nowhere compared to no matter large language or even for the car driving around the street. The street is relatively 2D and you have like navigation system, you have maps providing those data to train your FSD model. So then, okay, so there's assuming word model is there, they kind of understand and figure that out. Then it comes into action model, right? You have to control your parts as a robot to form up with this structure and to form up with different pressure and forces to have this structure steady to hold a microphone. And then think of next step. If I pass my microphone to my panelist, this move, also super, right? And she is interacting with me. And then how 2 robots can do this task together. So this is super complex. We're like only 1% there. I think that yeah, it's because of the limited availability of data, because of how complex this computing program is, because of all the time does it take. Like human nature, human creatures are amazing. They have been involved for like 10,000 years. But for a robot, this will take 3, 5, 6 years to catch up. But once we're there, the world will totally change. I think productivity will increase 100 times.
Yeah, so you're absolutely right. A lot of people didn't realize how data, well, we're in our investment same as data, data mode. So because Dr. Chu actually started the Google image search in year 2000. So that's why our investment theme has been lucky, always data, data, data. So a lot of people didn't realize how important data is in terms of humanoid robots. Like, for example, some people, they preach to us, they have a hand with 10 fingers, and then there's just no way to train this hand, right? So you have to hold your 2 hands together to do stuff, and then train the 10-finger hand. So it's just impossible. And then I remember there was this professor at UC Berkeley, he had a 100,000 year rule, meaning that consider the speed of collecting data right now for humanoid, we need 10,000 years of data to build something like ChatGPT in terms of humanoid. And so it is hard. So that's why we also invest in a company that doing data collection. So we synthesize data as well. And then, so my next question is for Kazuki-san, because if you really go to Stanford Laboratory and then, demo-wise, I definitely prefer humanoid. But money-wise, customer-wise, a lot of the company, they actually wanted to do like autonomous cranes or heavy industrial robotics. Do they still have a chance, or do you feel like there are biggest unsolved problems still in bringing AI into large-scale industrial environment?
Yeah, thank you for the question. Yeah, there are so many places where can be used robot inside factory or product itself. Yeah, this is one kind of slide, but we already automated like repeatable task or same size of the load. But if you go to shipbuilding cranes, every block is different size, weight, and it's so hard to automate. And then if you go to the next pages, yeah, that I saw many people doing mining, but if you consider about the construction site, the site is every time different. Like if you think about construction site in the New York City, Manhattan, and the countryside, that the requirement are totally different. And yeah, if you go to maybe next page, this is about factory stuff. I saw many robot automation was using the mass production, or I saw many digitalized product inside a small product. But in the area of the high mix, low volume, there's no robot and the digitalization doing by the humans stuff. So, and the worker is right now doing everything, but there's some area the robot can help, and the expert worker can focus on the expert. The robot, what's its kind of stuff is, you can see that might be more larger than what the human robot is kind of same as human. Or what is important for this robot is maybe the balancing like safety, productivity, and performance and the cost also, because high mix low volume, we can't take every data. We cannot bring everything to the simulation stuff. So we can guarantee stuff safety, but if there's a large robot, it's easy to injure people. So I think that the balance of the safety, productivity, cost, and yeah, those should be balanced, and those balance should be updated according to the innovation of the robotic stuff. And then how to solve this, the challenging, this balancing stuff? I think personally, I think we need have a good, we need to think about the non-functional requirement. Non-functional requirement is a maintenance support for future developing stuff. This robot should collaborate with human or machines, so the interface is important. This interface should be standardized and maybe we should collaborate with other competitors to make didn't change those interface long time. But on the other hand, we want to upgrade that AI software or mechanical part itself. How to realize this the balance of the updating AI and mechanical stuff instead of the keep the interfaces. For me, I think that the system should be the 3 layers. The bottom is really close about hardware stuff, and top layer is more close about the software side, and then there's the middleware. It's like a computer. There's device drivers, OS, and the application stuff. So the top of software should change according to each task or the AI updated. In the bottom part, we should change for hardware according to the task what we want. The interface or the middle layer should keep the always same even long time. So I did a PhD in Japan, and I found it that the robot which can be used longer is they have a 3 layers. So if you're interested, maybe you can try to see my PhD thesis. Thank you.
Thank you. Yes, I like visual, anything visual, very helpful. And then, so last but not least, we wanted to have a lightning round. And then, so definitely there are enormous excitement around physical AI right now. And then I wanted to ask, maybe name one thing that you feel like can separate a real long-term robotics platform from a short-term demo. It's hard.
I think
I would pick durable. Right now, I think the robotic hands, robotic arms are still very fragile. As Jerry mentioned, the human hands have so many 20+ joints, and robotic hands, if they want to emulate human hands, they will have so many motors. Those very tiny motors, very fragile, and they overheat very easily. Maybe you can let it work for a few minutes, then you have to use a fan to cool it down. So it can't really. You can do a demo, but to make them work for a long time, they have to be very durable.
That's why we invested one. Irma?
Exactly.
I would say two things. One is data. I think about continuous data loop, like full loops. So as your system is operating, it's actually deploying the policy, learning, adapting. How are you building this from the onset? And to me, the companies who are doing this right away, that's kind of much more durable. I think the other is dexterity. I think what is being described as there's some robotic arms that can have 88 ways of degree of freedom. And so I think about We Robotics in Korea who does this, but to emulate human capability, and we are moving quite closely there. This is not so future that it's not possible. I mean, in the next probably 24 months, I think some of these solutions are going to be in full production, and they have full dexterity, understand sensor touch, and to me, the ability to showcase that value today is the distinction between something that is a hype, a program something, and something that actually can manipulate, engage, and learn from its world.
Very helpful. Yeah, another investment.
Yeah,
Jerry?
I'll be brief. I'm a finance guy, so I would say it's more profitability or commercialization. It's actually, so I firmly believe what Tesla is doing, because you're manufacture large volume of a product at scale. You're managing the whole supply chain, you're managing P&L, you're managing your all of the costs, you have all of the R&D expenses, and your delivery, your insurance, and making sure the price is competitive. You can deploy large scale to the real world. I would say that this is super complex. If you're building like 10, 100, 1,000, it's kind of okay. But we're talking about Tesla is trying to deliver like 10 million, 100 million robots in the next few years. I think having that commercialization readiness from all the perspective and be able to get it done with an affordable price at scale and very steady. I think that's super hard, and that need a systematic work. So that's why Tesla is a $1 trillion company.
All right, Kazuki-san. What's
Uh,
important for you?
Can I repeat the question, sir?
Just name one thing, most important thing, can actually separate long-term, robust robots from short-term demo.
For me, I think there's already that the robot can use more practical stuff. When I see in the research and development, I saw many kind of like tactile sensation dexterration. But if you see this video, if you want to bring the heavy parts, we don't need to have a fine sensation. We can bring something, the only arm something can bring it. No need so much degree of stuff. So there's something we all can do to think about how to support or how to become friends with human already. So how to keep developing long term. I think more should focus on how the current technology can become friend with humans. So this is what I'm seeing.
I like that. So I feel like this panel really represent everybody, like the stakeholders of everybody. So so thank you so much. Let's give them another round of applause. Thank you so much for your expertise. And definitely we probably have a way to work together, and then we should do this again. All right. Thank you.